After huge information on geometrical meaning of the zeros of a polynomial, we will move to the next topic, relationship between zeros and coefficient of a polynomial. Before knowing the relationship between zeros and coefficient of a polynomial, first we have to recall how to factorize quadratic polynomials, by splitting the middle term. Now let us discuss the relationship between zeros and coefficients of a quadratic polynomial. As we know that, zeros of linear polynomial, ax plus b is minus b by a, which is equal to minus, constant term, by, coefficient of x. Suppose in general, if alpha and beta are the zeros of the quadratic polynomial, p of x is equal to ax square plus bx plus c, a is not equal to 0. Then we know that x minus alpha, and x minus beta, are the factors of p of x. Therefore, ax square plus bx plus c is equal to k into x minus alpha, into x minus beta, where k is a constant. This is equal to k into x square, minus alpha plus beta, into x, plus a beta. This implies kx square, minus k, into alpha plus beta into x, plus k alpha beta. Comparing the coefficients of x square, x and constant terms on both the sides, we get a is equal to k, make it as equation 1. B is equal to minus k into alpha plus beta, make it as equation 2. C is equal to k alpha beta, make it as equation 3. We know that B is equal to minus k into alpha plus beta, then substitute k is equal to a from equation 1, that is, k is equal to a. We get b is equal to minus a into alpha plus beta. This implies minus b by a is equal to alpha plus beta. So, alpha plus beta is equal to minus b by a. We know that c is equal to k alpha beta from equation 3. Then substitute k is equal to a from equation 1, that is, a is equal to k. We get c is equal to a, which is alpha beta is equal to c by a. Finally we get sum of zeros is equal to alpha plus beta is equal to minus b by a, is equal to minus coefficient of x, by coefficient of x square. Product of zeros is equal to alpha beta which is equal to c by a, is equal to constant term, by coefficient of x square. Note here that coefficient of x and x square are taken with their signs. Similarly for the cubic polynomial, it can be proved that if alpha, beta, gamma are the zeros of the cubic polynomial, ax cubed plus bx square plus cx plus d, then sum of zeros is equal to alpha plus beta plus gamma is equal to minus b by a, which is equal to minus coefficient of x square, by coefficient of x cube. The sum of product of zeros taken two at a time is equal to alpha beta plus beta gamma plus gamma alpha is equal to c by a, is equal to coefficient of x, by coefficient of x cube. Product of zeros is equal to alpha beta gamma is equal to minus d by a, is equal to minus constant term, by coefficient of x cube. Note here that coefficient of x, x square and x cube, are taken with their signs. Now we shall see some examples on the relationship between zeros and coefficient of a polynomial. Find the zeros of the polynomial 6x square, minus 3, minus 7x, and verify the relationship between the zeros and the coefficients. Let's find the solution. The given quadratic polynomial 6x square, minus 3, minus 7x. After rearranging, we get 6x square, minus 7x, minus 3, which is in the form of ax square, plus bx plus c. Using the quadratic formula that is, x is equal to minus b, plus or minus, square root of, b square, minus 4ac, by 2a. Comparing the given polynomial with general form, we get, a is equal to 6, b is equal to minus 7, c is equal to minus 3. and substituting the a, b, and c values in the quadratic formula we get x is equal to minus 7 plus or minus square root of minus 7 square minus 4 into 6 into minus 3 by 2 into 6, which implies x is equal to 7 plus or minus square root of 49 plus 72 by 12. That is, x is equal to 7 plus or minus square root of 121 by 12. This implies x is equal to 7 plus or minus 11 by 12. This implies x is equal to 7 plus 11 by 12, or x is equal to 7 minus 11 by 12. This implies x is equal to 18 by 12, or x is equal to minus 4 by 12. This implies x is equal to 3 by 2, or x is equal to minus 1 by 3. Therefore, the zeros of polynomial x square plus 7x plus 10 are 3 by 2 and minus 1 by 3.